Welcome to Hovercraft Physics and Chemistry for a tutorial on how to use the Google Sheets Trendline tool to develop mathematical models for sets of data. This video will focus on data that shows a linear relationship, and the next video in the playlist will focus on a data set that shows a quadratic relationship. Here's the sample data set that we'll be using for our analysis. This data shows the speed of a car as it slows down. You can see here that the speed of the car starts at 20 miles per hour and then decreases in speed. We'll go ahead and use units of miles per hour for speed, even though it's not standard for physics. We can see in the time column that we've recorded a data point every 2 seconds as the car slowed down. This data is meant to be realistic in that the measurements are not perfect. You could imagine maybe reading the speed off a speedometer on a car to the nearest mile per hour. The measurements wouldn't be perfect, but that's okay for our analysis. I've opened up a new Google Sheet. The first thing that you want to do is give the spreadsheet a descriptive title. I'll go ahead and call this Car Slowing Down, Time and Speed Data. The next consideration is typing the data into the spreadsheet. Column A should be the independent variable, the one that you choose in advance, sometimes called the manipulated variable. In this hypothetical case, we chose to measure the speed every 2 seconds, so time is the independent variable. I recommend in row 1 including a heading for the title. That'll save you a step when we graph the data. If I type in 0.0 and hit enter, the spreadsheet only shows 0. I want to include the tenths place to pay respect to significant figures. If I go back to that cell, I can use these buttons here to adjust how many decimal places are shown. I want to show 1 decimal place, so I'll click on Increase Decimal Places. If I want that setting to carry through for the whole column, I can click up here on A and make sure that we have 1 decimal place. Now I'll type in the other values for time. The dependent or responding variable should go in column B. Here, speed depends on time. Let's type those values in. Let me delete this now that we have the values entered into the spreadsheet. To create the graph, we want to highlight all the data and the headings. Then you can go to Insert, Chart, or you can find the Insert Chart button on the toolbar. Either one works just fine. Once you click on Insert Chart, Google Sheets will give you a suggested graph type. Here it's choosing a line chart, and I actually don't want a line chart. When we analyze data like this, we want to look at a scatter plot. We don't want a dot-to-dot type graph. So we go over to Chart Type here and click. This is a scatter plot. That's what we want. If it's not in your suggested list, you can scroll and find scatter plot down here. I'll go ahead and click. We've got a scatter plot or a scatter chart. We can check that our x-axis is in fact time. If for some reason the data doesn't look correct, maybe Google Sheets didn't pull in the correct x-axis data, you can click the 3 dots and remove the x-axis. I can click and pick the time column. Or another way to do that, I'll click Remove, add x-axis. This little button here allows you to select a data range by clicking and dragging, like this. Most of the time Google Sheets will get it correct, and you don't have to do that, but I wanted to show you how in case you need it. The Series tab is what's going on the y-axis. It has correctly chosen speed in miles per hour. We can see that on the y-axis here. That should be all we need to change on the setup part of the chart editor. If we go over to Customize, we get all sorts of options: chart style, titles, series, legend, horizontal axis, vertical axis, grid lines, and ticks. You can play around with changing these. But one thing we need to take care of right now is for some reason the horizontal axis label disappeared. So let me click on Chart and Axis Titles and fix that. The default is to look at the chart title. This is exactly how I would want to title this graph. The standard for titling a graph is y-axis versus x-axis. And here the y-axis is speed and the x-axis is time. I want to make sure that that label time appears on the x-axis. So I click on horizontal axis title and I can type in time in seconds. And we can see that it's showing up on the graph now. Another way to customize your graph is to just click somewhere in the graph. For example, if I click on the y-axis, notice that it opened up the chart and axis title for the vertical axis. Now what I'd like to do is to fit a trend line to this data. We can see that the data is not perfect. It bounces around a little bit, but it generally does follow a line. So what I'd like to do is fit a linear trend line to the data, and then try to make sense of that linear trend line. The Trendline tool is kind of buried in the chart editor. You want to go to Series, and then scroll down, and find the Trendline checkbox. I'll click it. I'll scroll some more for the details. First of all, the default trend line will be linear. And we can see that that has appeared on the graph. And for the most part, the data points do fall close to that trend line. You have some options on the appearance of the trend line, but label is the most important thing we want to look at. We want to click on that and use the equation as a label. This will give us the equation of that linear trend line. The equation for the trend line will show up in a legend. I'm going to click on that and make it a little bit bigger so that you can see it. So one thing I wish Google Sheets would do is write this in the form y equals mx plus b. It is in that form, but they don't include y equals. So let me go ahead and add that by double clicking and typing in y equals. So what we have here is an equation in the form mx plus b. M is the slope of the trend line. Notice it's negative because the speed is decreasing as time passes. This term here, which would be b in mx plus b, is the intercept. The trend line has an intercept of 19.8. We can kind of see why that's true. Our first data point was at 20. Now the trend line doesn't intersect exactly through 20, but that's fine because again, we said our data was imperfect. We know what it really means. The graph starts at about 20 miles per hour. The next thing I would recommend doing is replacing any variable with the actual variable name. So instead of writing y equals, I'm going to write speed equals, because speed is the y-axis variable. The x here is referring to the x-axis variable, which is time. I'll go ahead and change that. So now we have the slope multiplied by the x-axis variable, which is time, plus an intercept. I want to adjust those numbers so they reflect the data and have units. In science, a measurement is useless unless you know the units. So I'll go back to my data set and look at how many significant figures I have in most of my data points. Most of my time values have 2 significant figures, and most of my speed values have 2. I'm going to go ahead and round my numerical values so that they reflect the data. Let's first look at the intercept. It was 19.8. That's essentially 20. To indicate 2 significant figures, I could put a decimal point after the 0. And then I want to add units. This is the intercept. It's telling me where the graph starts on the speed axis. So it's referring to a speed in miles per hour. I'll put mph. Again, that's not standard for physics, but we'll go with it for this example. Let's think about the slope, negative 1.93. When you first learned slope, you probably learned it as a ratio of rise over run, and it's okay to think about it like that here. It's telling you a ratio of speed change per time change. Here, speed is measured in miles per hour, and time is measured in seconds. So the negative 1.93 value should have units of miles per hour per second, or miles per hour over seconds. That's rise units divided by run units. I'll go ahead and type that in, and I'm also going to round it to 2 significant figures. So now I have a linear equation, or a mathematical model, that describes how the speed of the car changed as it slowed down. I can interpret negative 1.9 here to be negative 1.9 miles per hour per second. What does that mean? Every second, the car decreased its speed by about negative 1.9 miles per hour. Another way to say that is the car's speed decreased about negative 1.9 miles per hour for every second that it was slowing down. We always want to be able to interpret the slope and give it a physical meaning when possible. The units aren't standard for physics, but this is a description of the acceleration of the car. Negative acceleration because it's slowing down. The intercept, 20 miles per hour, again would be interpreted as the starting point of the graph. It's your initial speed. The car was moving 20 miles per hour at time 0 when we first started collecting data. And then every second thereafter, it lost about negative 1.9 miles per hour. Now you know how to enter data into a Google Sheet to make a scatter plot. Furthermore, you can add a trend line to the data and use that trend line to develop a mathematical model. These are very useful skills in analyzing data. If you have any questions, please post them in the comments below. If you found this video helpful, I would also appreciate if you would subscribe to my channel. And as always, thanks for watching.